Very special case is a reading file which is a text, not a data table, but a text, like some story, lyrics for the song, novel, whatever. In this case, you use the function ReadLines, not readCSV, but this one. And in order to make it less boring, I will read some song lyrics and make a word cloud. This is a word cloud. And you have a few seconds to guess what is this song name. Okay, here is the script. In order to make a word cloud, you have to install and call the library Wordcloud 2. There is also library Wordcloud, but I like this Wordcloud 2 more. And here it is a small example how it works. You call the library. You will also need stringer library a little later. And then suppose you have a set of characters, which is A, and set of characters frequencies, which is B, and then you make a data frame out of it, and then you call word cloud, which is the illustration, and you will have this. So how to read it? The size of each letter is proportional to its frequency, and it can make a long and short list of any words in any text. You only have to make this data frame. So a little different example is this, that instead of typing in, you can also call letters and then ask for some random integers as a frequencies for it. Then in addition, you can sort it and then call the word cloud. Let's run it through. And then you have something completely random and a set of letters of different sizes. And importantly, you can ask for sorted and see that it is a table of frequencies indeed. So then what I did, I tried to find some song lyrics which is repetitive, and it came to me that some old good song of the Beatles, Hello Goodbye, would suit the purpose. Web pages with the lyrics of famous songs, and here is this lyrics, and you see that likewise to hello goodbye you see repetitive hello hello, and you say goodbye goodbye, and then you can write a script which can count all this stuff all together and give you some informative summary on the text ever written by Paul McCartney. And if you are interested in a song itself, you can always and so on, so you can find it on YouTube, no problem. Okay, after this, let's go back to the script. What I did, I copy-pasted the lyrics into the text file. As I told you, trying to fetch the text from HTML page is difficult in R, and you better not do it. and therefore you simply here is hello goodbye. You simply copy paste and keep it as a text. The text is not yet ready for counts because it has a punctuations and it's one line at a time. The readlines function read the text per line, so it's easy to see that this is how the text is read by readlines function. So line 1 is hello goodbye, line 2 the Beatles, that's the titles of the song, then empty line, and from here you have a lyrics, and it goes on and on. So at the beginning you have to clear the empty lines like this. You say lines should not be equal to nothing. Then you say I would remove first and second line. Okay. You can now check what the lines are and see that indeed empty lines disappeared and the title lines also disappeared. Punctuation stayed the same. This is very powerful line. G sub is the replacing all punctuation symbols all together to nothing, and then makes all characters lowercase. So actually two events happen in one line, and we call it new version of the text clean, and then we can ask what is clean. Now it looks better, no punctuations, everything is lowercase. What we have to do, we have to generate the text. Actually you can instead of G sub you can run string replace this line, but since we use this we don't need that one. And then with my Pythonic background I decided to make a single text out of lines. I run the loop, which is not typical for R but always possible. First I declare empty text, and then I extend the text with every line, and this way I generate the text. Now you see that everything is nicely separated, all low cases, no disturbing symbols. Now indeed it's a entire text, and now I have to cut it in every word in separate, and so to split it I use simply a space symbol. So this is how we come to words, and as soon as we came to words we can always count words by calling table function. You see now we have all frequencies, like hello is 39 times, woohoo is 1 time, nice to know. So from this table we can call frequencies table as data frame of a table function. And now we sort it. Why we sort it? It is to prevent geometric problems in placing these words of different sizes on your 2D space, to avoid some losses of some words. So you begin with the bigger words and then end up with a smaller one. It's algorithmically easier. And then you can check sorted, all sorted above 1. not that many. The most frequent word here is not hello, but say, and then goodbye is less frequent than hello. And if you like this analysis, you can go on and on. And now it's time to create the final figure. You can also play with the margins, but apparently it's easier to play with the size of the picture. And this is what you get, I think. And every time you click run, it will be slightly different. And you can export it, copy to the clipboard, for instance. And then notice that it's not the same. Its colors are now different. And also placing of the words is different. And then you can copy paste it into your documents. But before you save it, make sure that all, at least major words are present. For instance, if you keep size at 1 and 5, you see that hello is missing, and therefore you have to adjust window and size to one another. So it is so you see, you say and hello and goodbye are gone. There are some geometrical constraints in this Wordcloud algorithm, and therefore have to be careful. Now it sounds good, and hello and goodbye and say and you and something else maybe. And I, yeah, now it sounds acceptable.